Hey guys, here are some optional notes and video examples for those of you who just want a little bit more work with factoring. It is one of the trickiest skills that we try to teach you in Algebra 1 and Algebra 2, and I'm teaching you again in pre-calc, and so I just want to make sure you have every possible example to look at if you have questions. Okay, so first thing you got to look for is the greatest common factor. So basically, the greatest common factor comes from the fact that normally if I asked you to simplify this, when you learn in Algebra 1, the forward version of it is that you go ahead and you distribute this 4 to each of the pieces. So you get 4x plus 12. But when you pull out a greatest common factor, you're basically just working backwards. You're saying what number is common between 4 and 12. I'm going to put that number in the front. And then to figure out what's left over, you're just like going through and dividing out that 4. And so you're left back with 4 divided by 4 is 1. There was already an x there, so x. And then 12 divided by 4 is 3. Right? So when you work forward, we call it distribution. When you work backwards, we call it pulling out or factoring the greatest common factor out. Okay? Whenever possible, we want to factor the GCF to make our polynomial easier to work with. We want to take into account the factors of the constants, okay? So I'll do a couple examples, give you a second to try, and then we'll carry on in that way. So in this first example, between 6x and negative 2, I notice that both of these are divisible by 2, so I'm going to go ahead and pull out a 2. And then to figure out what's left over, you're going to treat it as dividing, by that factor, dividing by 2. So 6 divided by 2 is 3, that x is still there, negative 2 divided by 2 is a minus 1, and you're done. All right, in the second example, 9x squared plus 12x minus 36, I think these are all divisible by 3, so I'm going to go ahead and pull out a 3. And to figure out what's left over, we treat it as dividing the terms by 3. So then 9x squared divided by 3 is 3x squared. 12x divided by 3 is 4x. Negative 36 divided by 3 is negative 12. Awesome. All right, in this example, I have a 2y plus 4y squared. So not only do I have a number in common, but now both of them have at least a y variable in common as well. So they're both divisible by 2. So I'm going to pull out a 2, and then they each have at least one y in them, so I can pull out that y value. Okay. 2 divided by 2 is 1, and then I took out its only y, so I really just have the number 1. Plus 4 divided by 2 is 2, and then y squared, I took out one of those y's, so I have 1 left. Okay, go ahead and try those u-tries, and now I will go through them. So 15, oh, you're supposed to be pausing for the record when I say that, or else it's not enough time. So 15x plus 50, if I think those are both divisible by 5, so I'm going to go ahead and pull out a 5. Nope. There we go. 15x divided by 5 would give me 3, and then that x is still in there. 50 divided by 5 is 10. Nice. Okay, in this one, everything's divisible by 4, so I'm going to go ahead and pull out that 4. 4 divided by 4 is 1. Those x squareds are still in there. 4x divided by 4 is just x. 12 divided by 4 is 3. Okay, cool. And in this last one, I get 10x squared plus 15x. So they're both divisible by 5, and they both have at least one x in them. So I'm going to pull out a 5x. And then to figure out what's left over, 10 divided by 5 is 2. And then there was an x squared. Now I took out one x, so there's one x left. 15 divided by 5 is 3. There was one x, but I took it out. So now that's it. And that's GCF. Okay. So now factoring quadratic trinomials where a equals 1. So forwards, we call this foiling, right? So you multiply your first terms together and you get an x squared. Oftentimes we taught you to use the box method as one of these strategies, but also thinking of it as foiling. So you multiply x times x, you get an x squared. Then your outside pieces, x times 3, and you get 3x. Oh, I'm sorry, I should be setting this up properly. So there's one factor, and then there's your other factor. There we go, okay. So x times x gives you x squared. X times 3 gives me 3x. Your inside terms, 4 times x. So 4 times x would give me 4x, and then 4 times 3 would give me 12. If you're using your box method, then we just go through and we combine like terms. If you're using the FOIL method or distributive method, then you would get x squared plus 3x plus 4x all in a row plus 12. And then you combine like terms that way, right? So either way, whether you did it using box method or distributive method, you can just combine your like terms. So now my final answer would be x squared plus 7x plus 12. Okay. And so then backwards, all we're trying to do is we're trying to get from our standard form of our quadratic back to our factor pieces. And so you figure out what multiplies to your constant, right? 3 times 4 multiplied to my constant, and then 3 plus 4x is what adds up to your 7x. So a lot of times we use our table to do this. And so the steps are right here as well. So if there's a GCF, you put it in parentheses out front. Then we figure out what numbers multiply to our C value, our 12, and add to our B value. We often like to think that this is multiplying to AC because it applies to our next strategy as well. So what multiplies to 12 and adds to that 7, what we would get. You could test numbers if you wanted to, like 1 and 12, and so on and so forth. Doesn't work to add to 7. 2 and 6 doesn't work. 3 and 4, woohoo! Okay, so then that's how you get your back to your factors, x plus 4 and x plus 3. That's good. They should match, whether you're multiplying them together using distributive property or box method, and then whether you are factoring them, they should end up the same. Okay. All right, let's go through some examples of these. So in this first example, I have a quadratic. There's no GCF, and so I'm just factoring this. I'm figuring out what multiplies to 30 and adds to 11. And again, you can use your table. I emphasize in the video, though, that you eventually should be practicing this enough that you may not even need to use your table when you're just dealing with quadratics where the leading coefficient, that number in front of your squared term, is just 1. Okay, so what multiplies 30 and adds to 11? For me, that's 5 and 6. Should be for you too. Okay, and so then your factors, this factors into m plus 5 and m plus 6. Nice. All right, let's do the same thing with this one. So treating the same, it's got a no GCF. I have just a 1 in the very front, so I figure out what multiplies to 21 and adds to negative 10. Oh, I believe that one would be, if I'm using my table, we get 3 and 7. Those are close. Those make a positive 10. But if you make them both negative, they would still multiply to a positive 21, and then they would add to negative 10. So that's actually what I needed. X minus 3, x minus 7. All right, and this last one, w squared plus 7w plus 6. What multiplies to 6 and adds to 7? Oh, I think that one's an easy one. W plus 6 and w plus 1. Nice job. All right, so now go ahead and pause. Try the U-tries. And then I go. All right, for this one, what multiplies to 15 and adds to a negative 8? So I think like 5 and 3 multiply to 15, but those would add to a positive 8. Oh, but if they're both negative, right? So if I do negative 3 times negative 5, I would get positive 15, and then they would add to negative 8. Nice job. Awesome. Cool. For this one, what multiplies to 25 and adds to 10? Well, that would be, the only thing I can think of that multiplies to 25 is 5 times itself. Oh, yeah. So a plus 5, oops, and a plus 5, that adds to 10. Another way you could see this one written is if you have the same factor twice, a lot of times you'll see it written like this as well. So either of those would be acceptable answers. And last but not least, d squared minus 8d plus 7. So what multiplies to 7 and adds to negative 8? 7 and 1 add to positive 8, so if I make them both negative, that'll do it. D minus 7 and d minus 1. Awesome. Okay, nice job sticking around for these extra examples just to get that extra brain work in with factoring. Go ahead and you can take a break and then move on to part 2, or you can pause and try some practice.